So I wanted to end our discussion of muscle contraction with this question of how do muscles produce different amounts of force? Because muscles don't always produce the maximum amount of force all the time. They're able to vary or control the amount of force that they produce depending on the situation and what is appropriate for that particular situation, right? So recall that the nervous system is what controls the skeletal muscles, or at least for the most part, the nervous system is controlling the skeletal muscles. And recall that from our discussion of the neuromuscular junction and the synapse, that we saw that a single neuron will make synapses or make neuromuscular junctions with several muscle cells. Now this can be only a handful of muscle cells, that is, one neuron will make synapses with maybe only 5 or 6 skeletal muscle cells. Other neurons may make synapses with hundreds of skeletal muscle cells. And so the nervous system can using that setup, the nervous system can very easily control how much force muscles produce simply by controlling the number of muscle cells that are contracting at a given time, right? So think of maybe a situation in which you saw an object and you went to pick it up, and before you went to pick it up, it looked like a pretty heavy object, right? Like it looked like it was going to be a formidable object to pick up. You go and you pick it up, and it turns out that it's not particularly heavy, and you pick it up too fast, and you almost hit yourself with it. So what happened was that your nervous system essentially told too many muscle cells to contract, and so that particular muscle contraction was too forceful. So the nervous system can control or vary the amount of muscle force by selecting neurons or using neurons that only cause a few muscle cells to contract. And so often the nervous system only causes a few muscle cells to contract if that object is not particularly heavy. But if heavier objects or more strength is needed during that particular contraction, the nervous system will simply cause more muscle cells to contract, resulting in more forceful contractions. So let's look at this structure or this concept that we call the motor unit. Okay, so as I mentioned, the neurons from our nervous system, the neuron, which is the signal sending cell of our nervous system, makes synapses with skeletal muscle cells. It makes synapses with a few skeletal muscle cells, or to make synapses with hundreds of skeletal muscle cells. And we have a couple example motor units from this diagram here. So we have motor unit X and motor unit Y. And a motor unit is really kind of the basic description or basic definition of a motor unit is that one neuron that makes synapses with a particular number of muscle cells. So one neuron and all of the muscle cells that this particular neuron synapses with or makes neuromuscular junctions with is the motor unit. So this would be one motor unit here, and this would be a different motor unit. So notice that these two neurons don't have control over the same muscle. They each have control over different muscle cells. As I mentioned before, if our muscles only need to produce a very light amount of force, our nervous system makes use of small motor units. That is, it signals neurons that only cause a few muscle cells to contract. But if large amounts of force and high amounts of force are required from that particular contraction, the nervous system will use large motor units, and these large motor units will cause lots of skeletal muscle cells to contract. Because the more muscle cells we have contracting, that is, the more sarcomeres that are shortening, the greater amount of force that is going to be produced. Okay. So let's look at a quick example of the motor unit using both motor units X and Y here that we have set up. And so here we've got our motor units X and Y here. Our two examples, motor unit X makes neuromuscular junctions or synapses with 5 skeletal muscle cells here in red. And motor unit Y is going to make synapses or neuromuscular junctions with 7 skeletal muscle cells here in a tan color. Okay. So unit Y, that is motor unit Y, is always, when motor unit Y is stimulated to contract, motor unit Y will always produce more force than motor unit X. So here we've got a diagram of force here on the vertical axis, and these are just arbitrary units, but it still kind of paints the overall picture. And here we have our motor units that we're selecting to contract here on the horizontal axis here. So motor unit X, when we stimulate that motor unit to contract, that is, when these 5 skeletal muscle cells contract, they will produce only a certain amount of force, up to some maximum here. Okay, so that's the maximum amount of force that these 5 muscle cells can produce. If we were to stimulate motor unit Y with its 7 muscle cells or 7 muscle fibers, we would get more force than motor unit X, simply because there are 2 more muscle cells in this motor unit. So more muscle cells that are contracting equals more force. So motor unit Y will always produce more force than motor unit X. And the nervous system can actually recruit both motor units at the same time. So if it needs a lot of force, so let's say we need 12 muscle fibers worth of force here, it will recruit or it will cause motor unit X and Y to contract at the same time. So these amounts of force will sum, and so we'll get the strength or a muscle force equivalent to 12 fibers, and that's obviously greater than either 5 or 7 fibers alone. Okay. So when our nervous system needs more force, that is, or I should say when our muscles need more force, our nervous system will do what's called recruit more motor units. That is, it will simply signal more motor units to contract, right? So recruitment is simply increasing the amount of motor units or the amount of muscle cells that are being signaled to contract at any given time.